Please briefly summarize your education and professional background.
So my background's in landscape architecture. I practiced for about 10 years in the Chicago area and out in Denver before making the transition over to building materials and working with manufacturers. So now it's been about 13 years in the vegetated roof, amenity deck space, working predominantly with roofing and waterproofing manufacturers.
I believe you currently work for Siplast.
Correct, Siplast.
Okay, what do they do and what is your role with them?
So my technical title is Director of Green and Amenity Business. Basically means that I'm C-Class on-staff landscape architect. Um, but C-Plus is a total building enclosure provider. We're most known for our flagship products, which are SBS, modified bitumen, waterproofing membranes, commonly utilized in commercial structures. But over the last, I would say 10 years or so, we've really enhanced our portfolio to provide more comprehensive solutions to the designers, building owners that we work with.
Okay, so the main topic we want to talk about today is stormwater flooding in urban areas. So how is this infrastructure set up differently than non-urban areas, and what are the main problems with urban flooding?
So the biggest difference in an urban area versus an unurban area or rural area is the amount of pervious space. And so if we think about just throw a dart, middle of the country, Iowa, Nebraska, and just outside of their urban centers, you have lots of land, and stormwater can be managed usually at grade relatively inexpensively. When we get into our urban areas, so the other extreme of that, let's say New York City. We have densely urban areas. We have very low impervious surface, lack of vegetation. So there's no opportunity for that water to be to slowly get into the groundwater and process at grade. We need to look at alternative man-made tools really to help us manage the stormwater on site before it enters, in the case of New York, a combined storm system. So there's a number of ways that we do that. One of them is a stormwater detention vault, so a big concrete vault in the basement or a lower level of the building. But as our urban areas continue to grow, we do run into challenges with things like that. We could have a high water table. We could have maybe it's a new construction site and it's a brownfield. Maybe it's a sloping site. And so those all present unique challenges to the building and then how the building is going to meet the stormwater management requirement for the project, which is required to permit the project. And so more commonly, we're utilizing the rooftop to manage stormwater.
Okay, so I think one of those tools in which you're going to be getting to is something often called green roofs. How would you describe them? Our audience is probably familiar, but why are they so useful in becoming more of a standard in urban design?
So they're becoming a larger standard because I think the benefits are being realized. Maybe 20 years ago, well before I came into the vegetative roof industry, even 15 years ago, we were great at saying, hey, the vegetated roofs can manage stormwater, but we didn't do as good of a job at quantifying how much stormwater they can manage. And so through the integration of additional tools, being layers for detention or within the green roof media itself, we can retain or detain stormwater on the roof, which is really impactful because we're getting all of these other benefits that we see with vegetated roof, reduction of the urban heat island effect, habitat recreation, additional usable space, the aesthetic benefits. So we're getting a lot of these other benefits, but then if we can manage the stormwater as well, it becomes really powerful for a building owner.
You said the use has been increasing because the quantifying of the data has gotten better. Could you describe a little bit about what that means and what the data has been showing?
Ultimately, it's just how we quantify, right? It's one thing to say it, it's another thing to calc it. And depending on the tool and how it's being used, they're volume calculations, right? We're trying to hold a certain percentage of a given storm event on the roof. And um, so they're volume calcs, and whether that's the water retention within the growing media itself, if we're looking at even a paver blue roof, so the annular space between a waterproofing membrane and the bottom of a paver, what's that calced at? What kind of release rate do we need off of that? So it's something that civil engineers certainly have been doing for a very long time, and they're typical approaches or more common approaches with a detention vault. It's just, I think the vegetated roof industry catching up to having those calculations available, being easy enough to work with, where maybe we don't just default to a detention vault.
Are these calculations being derived from like live sensors on the roofs, or is it more just like engineering mathematical calculations of size and square footage and rainfall?
It's more the latter, Todd, because we're looking at really fixed components, right? So if it's a drainage retention component, whatever the associated ASTM test to understand what the retention value is of that product, what's the water holding capacity of the growing media, and then understanding what the depth is. And so the fun thing about it is that we can play with those layers to help meet the stormwater management requirement. So we can add more robust retention layers. We could increase media depth as long as it fits within our project thresholds to really tailor the assembly so we're not over designing or under designing it, and that we're getting the right amount of stormwater management for the project. And it also helps us keep the project on budget, right? We want to make sure we're not over designing.
Okay, I'm hoping you can maybe elaborate a little bit on what green roofs are. Like, what would you describe as like an ideal green roof that you'd have everything going the way you'd like it, or perhaps versus maybe like a what's typically installed, or maybe even a poor example?
That's a very nuanced question. I think it might be easier to talk about what the most common type of vegetated roof is, which is, I think most commonly when we say green roof, people think a sedum roof, right? 3, 4 inches of growing media, a sedum mat, there's a drainage, water retention layer, root barrier, filter fabric. Probably difficult to follow as I was bouncing around the assembly there, but contains all those components over top of a roofing and waterproofing membrane. So that's the most common type. And sedums are chosen not because it needs to be a sedum to be a vegetated roof. Sedums are chosen because they're relatively drought tolerant. They work in a large swath of the United States. They tend to have challenges in overly humid climates, so the Southeast. But the rest of the country, they can be successful. But really, vegetated roofing as a whole is everything from that, what I would call pretty simple, straightforward, extensive vegetated roof, so your thinner assemblies, all the way to large, intensive roofs, parks on structures, parks over podium, even planters on amenity decks, where maybe 75% of the roof deck is a pedestal paver assembly or some sort of hardscape, top and slab. But then we have a vegetation component to that too. So it's a wide range, and then everything in plant material from those sedums and succulents, herbaceous perennials, all the way through large mature trees are possible. It's just how we design that assembly to meet the project design intent, what we're trying to do with stormwater and all of those factors.
So it sounds like it's a pretty much a case by case situation. We've got to take in the environment of the project area and all the different factors of the building design.
I think it's best if you can. Certainly, we have a vegetated roof module, which is a little more fixed and known quantity in terms of what you're getting. I, as a landscape architect, and certainly when we're considering stormwater, I think that there's a significant benefit to a layered assembly that's really tailored to the specific project. We're able to really dial in that media depth. We're able to dial in if there's stormwater component, stormwater retention or detention for the project, and really fit the project so that it's going to be as high performing and resilient as possible for that building owner. We're a manufacturer. Our goal is to sell material and provide the right solutions for the right project so it's successful, so that we can continue to work with the designers we work with. It's not in our best interest to sell a vegetated roof that we think is going to fail. So I really like the ability to look at it at a project by project basis.
So for those designers and engineers who are relatively new to, green designs, but they know that they'd like to get into it, how could they, start those steps to get involved and to learn more about what is possible in their area and in their projects?
I think kind of understanding what the project objective is. So are we doing it to meet a municipality requirement? Is it being stormwater driven? And then who's on the project team and who are the best stakeholders? Do we have a landscape architect on the project? Is this just going to be your standard stock 4-inch green roof? And really trying to understand what the objectives are there. Stormwater is a big thing because we need to understand what the values are early on. So working hand in hand with the manufacturer, they can help derive those stormwater management values so that we are working with those quantifiable numbers as early as possible, and not just the stormwater, but what's our saturated bulk density. There's a structural implication for that. So really starting to just going from, hey, that's a green surface on our rendering that's supposed to be vegetation to what do those layers look like? What kind of protection do we need for the membrane? One of the benefits of working with a company like Siplast is that we have a number of different membrane solutions. So we're not trying to put a square peg in a round hole when it comes to understanding, what type of membrane might be is the best solution for that project based on the structure itself, but also what are we doing on top? We have that push and pull, and if there was one type of membrane that worked in every application, we'd only have one type of membrane available in the marketplace today, and that's certainly not the case. So.
Okay, so with the pretty obvious increase in flooding that's been going on, how do you
Mhm.
feel that the industry is taking into, things like green roofs and other kind of urban stormwater design? Are these approaching levels that you think are adequate, or does more need to be done?
I think one of the reservations in fully buying into vegetated roofing is the maintenance aspect, right? We have a landscape that does require maintenance, even if it is a sedum roof, requires some eyes on it a couple times a year to keep it healthy. If it's not healthy and living, it doesn't serve the same function as it does, uh, uh, a dead or a brown roof, right? So I think that's some of the hesitation. I think as flooding has increased overall, we're seeing greater interest in any sort of tool that provides us an alternative solution to what we have, because the stormwater management requirements only seem to be going up. Greater flood events, larger flood events are driving those numbers up, and those are set by the municipalities. So our civils certainly on in major urban areas where we have lot line to lot line construction, I mean, they need to be able to get creative. And so I think the vegetative roof industry as a whole has certainly focused on stormwater pretty heavily over the last 10 years, and will continue to do so. I think we're seeing more and more projects take advantage of the tools that we have to offer, and that's driving it. But ultimately, it's all driven by the municipality and what the requirement is, and that as that's continued to go up, so has the interest.
So for those who have that hesitation on maintenance, how do you try and persuade them or assuage their fears of such problem?
I think we have to look at all of the benefits that the vegetative roof is bringing to the project. The other biggest one that pencils, if we're taking care of stormwater management, the other one that really pencils is if you're specifying an appropriate membrane in that application and you're putting a vegetated roof over the top, you're getting significantly longer lifespan out of that roof membrane. So if we think of that from the perspective of a long-term building owner, we're getting a much longer um, lifespan out of our membrane and eliminating the cost of having to re-roof sooner because we're taking away exposure to UV. We're putting additional layers in between any kind of physical traffic or wear and tear that might happen to the membrane and the membrane itself. So starting to look at that, and then all of the other aesthetic values increase in lease lease values, um, habitat recreation, all those great things.
In terms of maintenance, who typically does that? Is that an engineering situation where you've got to consult with engineers and see how it's working, or is it more of like a grounds maintenance kind of a position?
It usually would fall within a landscape contractor's uh, um, scope, but it also depends on the scope of the green roof. It might be able to be managed by a building superintendent. I think the most critical thing is understanding that there needs to be eyes on it a couple times a year. We can't just leave it up there like we do our roof membrane. It doesn't tell us like the roof membrane when there's an issue, right? The membrane leaks. If the roof's leaking, it's telling us. If nobody's getting out on that vegetated roof, the plants aren't telling us that they're dying. So it's not a significant add to a project. It's more to me, it's more about awareness and understanding what that looks like.
Is that something that might be able to be done with like sensors and cameras, or does it really need a human aspect on occasion to really check things out?
A component of it could be done with sensors and cameras. I think there's always going to be a human element because it's an inspection, and so there's a lot that we can see with a little bit of poking and prodding, drain inspections that we can't see just with a camera on it.
Okay, so we've talked a decent amount about the green roofs and the vegetative roofs. Are there some other solutions that help contain urban flooding?
Yeah, so blue roofs are a concept that have been around for a long period of time, and so blue roofs basically create a space within the rooftop, and they marry with a flow control drain. So a drain body that has either an aperture in it or weirs that reduce the flow through that drain. And so we're parking water. We're finding space to park water for a period of time, typically in the range of 24 to 48 hours, so that that water can slowly leave the roof. And the objective there is to make sure that we're not overcharging our existing stormwater infrastructure all at the same time. The reason we have urban flooding in most cases right now, and if you're in a major urban environment, my guess is that you're probably seeing, even in moderate rains, you're probably seeing some localized flooding around a storm drain. And that's largely because as our urban centers have continued to grow, we aren't incorporating that impervious space. And so all of that water is hitting that storm drain at the same time, and it's overloading it. And so blue roofs, just like a green roof, are typically holding water. You could do it beneath pavers. You can do it by adding a structural voiding unit within the vegetated roof assembly. And then that flow control drain is helping to moderate the amount of stormwater that's leaving the roof. So another tool on the same plane on the roof, but just another way to potentially manage that stormwater.
Okay, that's good to know. So what would be then the pros and cons of either a blue roof or a green roof? Is it just based on the building and the project, or is it financial?
So the pros and cons is kind of the same. It's about having the right tool for the right application. And so a blue roof tends to be a little bit larger volume of water. Marrying anything with that flow control drain is going to that's a detention based requirement. In stormwater, we often have retention requirements and detention requirements, and a bulk of municipalities have detention requirements, meaning they want to park water for a period of time and slowly release it off the roof versus retaining it is holding on to it for indefinitely until it's used probably by building systems. So passive irrigation or flushing toilets or irrigation, things like that. So um, green roofs inherently retain stormwater, right, within the depth of the growing media in the drainage and retention element. We have to integrate additional components to find that space to park water. So it's really just about where's the project located, what's the requirement, and then what are our options? What do we want to look at to make sure that we're approaching it as efficiently as possible, understanding that each layer has a cost associated with it, or a weight associated with it. And so it really does boil back down to project specific approach.
Okay, so if you could offer some advice to our engineers in the audience, what might they need to know about urban stormwater mitigation that they can use to do their jobs better and create more effective designs and solutions?
Well, first, I think they're doing their jobs exceptionally well. But I would say, this is a managing stormwater on the rooftop is an exciting opportunity to approach projects differently, and more integrated approach rather than just burying our stormwater, using the vegetated roof or paver deck, and all of the benefits that that's inherently bringing. to really add value to the project. And when you're marrying that with sound membrane and potentially a comprehensive guarantee from a trusted manufacturer, I think that can be a really powerful message to a building owner.
Okay, similarly, how could you suggest that they might be able to lead us toward a better environment with better designs, like and show some ways to, I guess, I kind of almost push for these things, perhaps with like municipalities and the owners. What do you think the engineer's role should be into trying to get more of these urban flood management designs into practice?
Well, I mean, they're already doing it because they have to do it for the project, right? So it's why would you choose this over the other? I think, and as a civil, again, it's if we're putting it in a box in a lower level parking, we're always running up against parking count challenges. If we have a high water table, we might be having to put that detention tank on the first floor where we could be otherwise utilizing that space for retail or, there's a high dollar value associated there. So I would suggest, and it's not going to be for every project because it does tend to be, it might be more expensive, but I would suggest, hey, have we at least considered putting this on the roof? If you're already having to put a green roof on the project because it's mandated by the municipality. And when I say mandated, they might not have a value associated with it. Their goal might be stormwater management as a municipality with their code requirement, but they might not be actually calculating the stormwater that's associated with it. So if you're already required to put a green roof on, you should absolutely be looking at that green roof to understand how much stormwater can we manage and can it at the very least minimize some of my other stormwater management methods that we're already utilizing on site. Because if you aren't taking advantage of at least that, then you're probably doing your building owner a little bit of a disservice.
Okay, so as these designers and engineers are working on these projects, what types of standards and codes should they be working towards? I know as the storms are picking up, do they need to change what the definitions of necessary stormwater management are?
No, ultimately stormwater is it's the requirement's going to be dictated. Right? We could approach it altruistically and say, hey, we're going to bite off more than we have to chew here. But I think ultimately it's just dictated. So it's understanding the other benefits that we're bringing to the table through vegetated roofing, and then how much of that requirement can we manage all of that on the roof? Can we manage at least part of it and alleviating some of our other requirements? I think we all have a tendency to do what we're comfortable with and what's worked for us previously. There's a comfort level, and certainly in engineering, there's not always a need to reinvent the wheel. But I think in specific projects where perhaps there are site constraints, there are project technical constraints. I think I would implore engineers who maybe have not utilized the rooftop for stormwater management to reach out to myself or another trusted manufacturer and just see if you can run the calc, see if we can run a pro forma to understand what kind of impact it would have on the project if we did start managing it on the roof. I mean, it's the point of contact for the rain onto the structure, onto the site. If we can manage it there without having to move it into a bunch of other systems and add mechanics, I see that as a pretty big benefit.